let's take a look at our warm-up. Today's agenda will be doing, as usual, warm-up, homework questions, mini quiz, and then today's topic that we're learning about is simplifying radicals, so square roots, cube roots. We may have dealt a little bit with it before. Okay, so number one, we have 7x squared y to the 10th over 21x cubed y to the 6th. What do you guys want to do first? We are doing the first at first. So what should we do in our first problem? Simplify. What do you want to simplify? X and y. Should we also simplify our numbers? Yes. So we need to simplify the numbers, simplify the like terms. Let's start off with our numbers. 7 over 21. What can we reduce that down to?
1.
Good. 1/3, so 1 over 3. Now next up we have our x's. What do I do when I'm dividing like bases? The bases are the same, and I have exponents. What do I do when I'm dividing? Subtract the exponents. So what is 2 minus 3? -1. So since it's negative, where's it going to go? Down. So it becomes x to the first in the denominator. So again, x squared over x cubed, that equals x to the negative first. And that negative means it gets sent to the bottom. Remember, once we move the base, the exponent becomes positive. Once we move it, the exponent becomes positive. The negative tells me you need to move it. So once you've moved it, you no longer need your negative. Alright, so then next we have our y's. Y to the 10th over y to the 6th. What does that become? Good, y to the 4th. And is that going to go on top or on top? Top. Good, it's a positive exponent, so it goes on top. Now we don't really need to write the ones. We just have y to the 4th on top. And we don't need to write an exponent of 1 either, so over 3 goes. Any questions on that one? So again, what we learned last class, what you should have done on your homework, is that concept that when we divide, we subtract our exponents. And just like all of our other properties, in order to do this, we have to have the same base. I cannot now combine my y and x because it's not the same base. Yes. So what this is here is technically x to the negative first over 1. So that means it gets sent to the denominator because it's a positive. We just did that both in one step. Good question. Other questions on number 1? Okay, so number 2, again, let's start off with our numbers. Can I reduce 8 over 2? Yes? What does that reduce down to? 4 over 1. So next, let's take a look at our x's. Ooh, we see we have a negative exponent there. So you can do this a couple of different ways. You can first move your negative, or you can go ahead and subtract them and then move it. So if we subtract them, we would have -4 minus 2. What does that give me? -6. So where would that mean it goes? On the bottom. So x to the 6 in the denominator. Again, x to the -4th over x squared is x to the -6, -4 minus 2. And because it's negative, it gets sent to the denominator. If you need to do that individually in different steps, that's fine. Now let's take a look at our y's. Again, we have a negative exponent, so we can either move it or we can subtract it first. Since we subtract the last one, let's move it first so you can see what this looks like. So my y to the -3rd, that's what needs to get moved since this has the negative exponent. So this here is going to get moved to the denominator. So I have y to the 6th over y cubed. Now we simplify from here. What does y to the 6th times y cubed give us? Y to the 9th. Okay. So that's your answer there. Again, if you would have subtracted, -3 minus 6 would be y to the -9th, which means it gets sent to the denominator. You can use either method. Subtract it, then move it, or move it, then divide it. Alright, questions on number 2. Any questions at all on the one? Okay, so let's take a look at your homework. Alright, so today we're learning kind of a different concept. These are radicals that we're dealing with, no longer exponents, although a radical technically can be written in exponent form. It's something that we're not going to deal with for now, and we should have all of our phones away. Thank you, sir. Alright, so radicals do relate to exponents, but we are going to keep it strictly in the radical form as we see here. Now, we have dealt with square roots before, but has anybody dealt with simplifying square roots by hand? No. Okay, good. So this is a new topic for all of us. Awesome. Alright, so first some terminology here. Now, we've dealt solely with square roots, right? But we will also deal with cube roots, fourth roots, fifth roots, sixth roots. You can have any type of root. And the root, or what we call the index, is that little tiny number here. So that this piece here, the y, this is called our index or root. You'll hear me refer to it both ways. Index or root. Alright, does anybody know the technical term for this guy? Starts with an R. Alright. Radical? Why did you say it? Alright, so this right here is what we call a radical. A radical. Okay. Now, I think this is the hardest one to remember. Does anybody remember what the value under your radical is called? This is a weird one. An R. This is called a radicand. Has anyone even ever heard that word before? Yeah, it's a weird one. Radicand. Okay, so you will hear me refer to these with those specific terms. So when I say, all right, your radicand is 18, you know that the 18 is what's under your square root. When I say it's a fourth root, that means that my index, and the little number here, is going to be a 4. Okay? So you will hear me use these terms. All right, now I want everyone to get out their calculators. Well, why not? Get out your calculators. So we're going to do some punching in of numbers. Anybody else need the calculator? Okay, so let's review where the square root and the radical buttons are. Jonathan, head up, please. While we're waiting for that to see if it works, I'll just show you by hand. Alright, so on your calculator, you have an x squared button. Locate your x squared button. Still loading them. Still loading them. X squared button. It's near the math button. Is there anyone that does not see the x squared button? Right there. Okay, so you'll see written in a different color above x squared is that little radical, right? The square root there. So that allows you to get your square root. Now, in order to get that above it, you have to hit second and then the x squared button. And you should see a square root appears. Here we go. Right, so again, above my x squared button here is a little square root. And in order to get that, we have to hit second x squared. And that should pop up as filter. Now this is only square roots. Okay. So let's do the square root of 9. Does anyone know what the square root of 9 is? 3. Now say you need the root, such as you need for number 4. Does anyone know where the cube root button is?
Yeah.
You do? Where?
Math.
Math, yeah. Math, and then option 4. Option 4 gives you your cube root. So let's do the cube root of 64.
Cube root. 4.
And that's 4. Okay. Now, let's say that it asks for the 10th root or 12th root or any other number. So let's say, Philip, give me a number.
23.
All right, let's say it asks for the 23rd root of, Drew, give me another number. All right, let's say it asks for the 23rd root of 22. So you have to first type in your index for the older calculators. So those of you that have the older calculators, you're going to want to type 22 first, and then hit math, and option 5 allows you to use whatever root you need to. Alright, so those of us with the newer calculator, it will automatically move it up into that little spot for that root. Alright, so the 20, oh wait, it was 23rd root, wasn't it? Okay, so 23rd root of 22. 1.14. So those of you that have a calculator where it doesn't move it up, you'll see it looks like this. 23, and then I think it does like that, parentheses. Alright, so again, you have to type the index first, then hit that button for whatever type of root, then you can type it in. Alright, so again, we type our index first, 23, then I hit math, and option 5 lets me do whatever root I want, and then I type my radicand. Okay. Questions so far on buttons and where that is in fact? Okay, so now try doing the square root of, Natalie, give me a number. 3? Alright, so let's try doing the square root of -3. So I want everyone in your calculator to do the square root of -3. Jonathan, head up, please. This is the last one I'm telling you. What do we get when that happens? What does it say? Error. What does the error message say? Non-real answer. So we cannot take the square root of a negative number. When we have a negative number underneath their square root, it's going to give us an imaginary number. But we're not dealing with imaginary numbers in here. You'll deal with that in algebra 2. So for us, we do not have an answer. So that's our next spot here. Remember, we cannot take the square root of a negative number.
Anyone know if we can guess as to why that is? What's negative? She checked negative. Again? Negative 2 times negative 2.
Positive 4.
Right? What's 2 times 2? Will I ever get a negative 4 when I'm multiplying it by itself?
No. So that's where it comes from, is that square root means, okay, what number squared would give me that? So any number multiplied by itself is going to yield a positive value, because a negative times a negative is a positive times a positive is a positive. So that's where that comes from. And again, you'll deal with imaginary numbers in algebra 2, but for here, we don't deal with imaginary numbers. Alright, so we cannot take the square root of a negative number. This is also true for any other even index. Even index. So our root, if it's an even number, only evens, we cannot take the root of it. So even numbers would be like 2, 4, 6, 8, so on and so forth. Alright, so the square root, the 4th root, the 6th root, the 8th root, we cannot take those of a negative number. Okay. So I want you to go ahead and do number 1 through 5. Use a calculator to evaluate the following radicals. Round to the nearest hundredth if necessary. So I'll give you about 1 minute to do those. So this is just saying the positive value and the negative value. So whatever your answer is, you just have the plus and minus in front of it. We want the positive value and the negative value. It's two values. Alright, we should have gotten these as our answers. Are there any that you guys did not get the first? Straight plug it in here. So again, we looked at where the cube root button is, we looked at where the square root button is. Make sure you have your negative in the proper place. And make sure that you do seal what's underneath in parentheses. Negative 27 should be in parentheses. Your calculator, I think, prompts you within parentheses anyway, so you have to just seal it. Okay, so taking a look at the next piece. Evaluate the square root of b squared minus 4ac for the given values. Round to the nearest hundred. Now, this is actually a piece of what we call the quadratic formula. Has anyone heard of the quadratic formula? Heard of it? Okay, you've at least heard of it. That's good. So we will be doing the quadratic formula. I think it's next month. It is coming up soon. It's a method for solving a quadratic. So this is just a piece of it. But since we're focusing on squared today, we're going to just look at how to evaluate the square root here. So evaluate b squared minus 4ac for the given values and round to the nearest hundred if necessary. So evaluate, that means all we do is substitute in our values, right? They give us what a, b, and c are. So b squared means 5 squared, is 5, minus 4 times a, which is 4, times c, which is 1. So we should all be writing this down. Square root of 5 squared minus 4 times 4 times 1. Notice that all of that is underneath my square root. And notice I also extended out my square root to include that all. You too, when you write out your square root, should make it long enough to cover everything that's inside of it. In fact, we dealt with this at the beginning of the year, where some values were underneath your square root and other ones were left out. And the biggest mistake we saw was that people left everything underneath the square root. You didn't know which one was inside, which one was out. So make sure you pay attention. The square root goes all the way to the end of my C, so it should go all the way to the end of my values. Okay. So you can actually put this in your calculator as is. Square root of 5 squared minus 4 times 4 times 1. While you do that, I'm going to do it algebraically. And punch it in your calculator so you can get the same thing. Did we get 3?
Yes.
Good. Good. And again, a couple key things is make sure you are using proper parentheses. We didn't really need parentheses here since you have that multiplication sign that you use on your calculator. But let's go ahead and set up number 2, just so you can see why it's important to use parentheses. Alright, so b squared, what does that mean? What's that going to give us? 7 squared. Good, so 7 squared minus 4 times a. What's my a value? Good. Notice here it's important to use parentheses because it's a negative 3. There's more than one piece that you're typing in your calculator, so your calculator needs to know there's parentheses. Alright, times a times c, and c is 5. Alright, go ahead and punch that into your calculator. What did we get for answer? Beautiful. That's what I got. Notice it says round to the nearest 100. So it means 2 after the decimal place. So 10.44. Questions on that? Okay. So far, all we're doing is using our calculator to evaluate this, to get the numerical values. Alright. For sake of time, we're going to skip through and continue moving on. Okay, so just like we prefer fractions over decimals, we don't ever want a decimal answer, we want the fraction answer. We also prefer to simplify our radicals instead of estimating. Because when I punch this into my calculator and get a decimal, 10.44, that's not the exact value. The exact value is actually, if we were to reduce this here, square root of 109. This is my exact value. 10.44 is actually just an estimation because it's a decimal that goes on for forever and ever. So we lost all the values that were after 4. So to help us simplify, we use product property and quotient property. So whenever we're able to simplify our radicals, we should. Right? You only give us decimals when we tell you to give us the decimals, and we'll tell you what to round. Alright, so to help us simplify, we use the product property. So this is your first one. What operation is product? Addition, subtraction, multiplication, division. Multiplication. So the product property here is when we are multiplying, and it's the same index. Notice these are both the same index. Also, I don't think we mentioned this up top. Whenever you have a radical without a number in your index, this is an assumed index of 2. It's a square root. We don't ever write in the 2 for a square root. You can. It's not mathematically incorrect. It is proper, but the radical by itself indicates a square root. So down here, these are both square roots. It's the same index. Right. So when we have the same index, and I just multiply what's underneath together, I multiply my radicands together. So this would be the square root of A times B. So again, as long as my index is the same, I just multiply what's underneath together. So let's say, for example, I have square root of 8 times square root of 4. What would that give me? The square root of 8 times 4? And what is 8 times 4? 32. So again, as long as your index is the same, we just multiply what's underneath together. So we get square root of 8. So that's our product property. Now the quotient property. Alright, addition, subtraction, multiplication, division. What does quotient mean? Division. So here's where we have two radicals that are being divided. And again, notice the same index. These are both square roots. So our quotient property is that we can actually just do the square root of the whole fraction. So divide the inside and then take the square root of it. Alright, so these are two extremely important properties for us. And it goes both ways. If I have multiplication, I can break it up. If I have a fraction, I can break up to square root of the top and square root of the bottom. So an example of this, what if I had the square root of 12 over the square root of 3? Square root of 12 over the square root of 3. Right, square root of 4, because it's the same thing as 12 divided by 3, which is 4, so square root of 4. And what is the square root of 4? 2. Good. So again, when we are multiplying, as long as my indexes are the same, I multiply my radicands together. When I'm dividing, as long as my indexes are the same, I divide my radicands. Questions on those two properties? Okay. Let's move to the back side. Alright, so first we're going to take a look at square roots. How to simplify square roots. And a square root looks like that. How to simplify square roots. Alright, so our first thing that we're going to do, well, we are simplifying. But the first thing we want to do is take our radicand and actually break it down into its factors. So break down the radicand into its factors. Break down the radicand into its factors. And factors are the numbers that you multiply to get that value. It's the prime numbers you multiply by to get that value. So the smallest numbers you pick. So we'll kind of do number 1 together as we go through the steps so you can see what we're talking about. Alright, so 44. we want to break this down as much as we possibly can. Alright, so 44. Now, a hint. Whenever you have an even number, you can divide it by 2. Sometimes you can also divide by 4, but you know you can at least divide it by 2. So 44 is even. We know we can definitely divide it by 2. Okay, so we're going to do some division by hand. 2 goes into 4 how many times? 2. Alright. And 2 goes into 4 how many times? 2. Alright. Next. Alright, it's still an even number, so we can divide by 2 again. Alright. 2 goes into 2 how many times?
1.
Good. And 2 goes into 2 how many times? Good. Can we break down 11 at all? No. No. Alright, so we've broken it down. 44 is the same thing as 2 times 2 times 11. That's what we mean by break down into its factors. We have 2 times 2 times 11. Alright, circle the pairs. Because this is a square root, that means my index is 2, right? Because it's a square root, my index is 2. So I need to have 2 of a kind in order to pull it out in front of my radical. So circle the pairs. Alright, I've got 1 pair of 2's. Right? A pair means 2 of the same kind. So I've got 1 pair of 2's. Circle the pairs. Okay. Now that we've circled our pairs, bring 1 number from each pair outside. So here's my square root of 44. So here's my pair of 2. I'm going to take 1 of them and bring it out in front. So I have a 2 out in front. Then leave out the other number. So now I've taken care of those guys. It's a pair, so I bring 1 out in front and leave out the other guy. Next, leave any other numbers inside. So I still have my 11 left. That stays inside my radical. And then simplify. So what we're doing here is we're breaking it down into its factors. And then because the square root requires 2 of a kind in order to bring it out in front, we look for our 2 of a kinds or pairs. We bring 1 out in front and then leave all other numbers inside. So our final answer here is 2 square root of 11.
And guys, we decided to divide by 2 because you want to find the smallest number you can pull out. So 2 was the smallest number we could pull out, other than 1. We don't want to pull out 1.
And so keep in mind, and I'm just going to write a note up here at the top, that even numbers, you can have a factor of 2. So if you're not sure where to start, if it's an even number, just do 2. If it ends in 5 or 0, then you can factor out a 5. Alright? That'll get you a little bit of a jump start, so you're not trying 3 and 4 when it's actually 5. Those are just a couple little things.
Which you definitely need 2 and 5 are the only numbers.
Right. Right. But that's at least your starting point to get you going.
If you're still remembering that, try 2, try 3,
Try
try
4,
5.
try 5.
2, 3, and 5 are even more. 4 would be.
Right, would be right. So let's go and put that in a box. 2, 3, and 5. Or typically, your most from there, you would go 7. Notice these are all prime numbers. If you forget what the term prime means, that means you cannot break it down any more than it is. Its only factors are 1 in itself. So I cannot break down 2, I cannot break down 3, I cannot break down 5. So we're looking for those prime factors. Alright. So again, we are breaking down the radical into its factors. So in this ladder method here where you're divided out, circle your pairs, and when you have a pair, you bring 1 of those numbers out in front. You disregard the other one, you throw in the trash. Then anything else that's left stays underneath the radical. Okay? Alright, so another way that you can do this, if you don't like the ladder method, something that I've had my students do in times past, so I have the square root of 44. we break it down into its factors. So you might think 4 times 11 or 2 times 22. It's the exact same process as your ladder method, just a different organization. So 2 times 22. 22 breaks down into 2 times 11. I cannot break them down anymore, so these are my factors. Same idea. I have to have 2 of a kind. So here's 2 of a kind, that comes out in front. 11 is all by itself, he stays underneath. Right? So the exact same process, just whichever method you prefer to break it down. Alright, any questions on number 1? Okay. For those of you that can understand this next part, this is really helpful for you. So pay attention to this next part here. Technically what we're doing is just breaking this down into any number square, perfect squares. So the square root of 44, and I know I'm diving into this a lot, but I know there are some of you that understand what's going on here, and this will help you accomplish it faster. So what we're doing is we're trying to find any perfect squares. So 44 is the same thing as 4 times 11. And you'll notice that here, 2 times 2 is 4, 4 times 11. 4 is a perfect square. So what we're technically doing is the square root of 4 times the square root of 11. Well, the square root of 4 is just 2. And then square root of 11 I can't do anything more with. This is what's happening behind the scenes of when we're doing our ladder method. But for those of you that understand that, it would be quicker for you to actually break down 44 just into 4 and 11 and recognize that square root of 4 is 2 and square root of 11 I can't do anything with it myself. So those of you that recognize that and can use that, feel free to do so.
If that looks confusing, erase it from your head.
Yep.
With the first one.
But for those of us that struggle with that and understanding what's going on in the background, we're going to stick with our ladder method. Questions on that? Okay, so let's do number 2 together. Alright, so anything sitting outside my radical, I don't need to break down. It's already outside of my radical. I'm only breaking down what's inside of it. Okay, so we have 48 here. So let's go ahead and break down my 48. Alright, so it's an even number, so we can divide by 2. 2 goes into 48, so 2 goes into 4 times, 2 goes into 8 4 times. Alright, keep breaking it down. We get 2 times 2 times 2 times 2 times 3. Alright, so right now we're just working on 48. Okay. Now, when we're dealing with our variables, it's the same idea. We have to have 2 of a kind to pull it out. So let's go ahead and just write out what x cubed is. X cubed is x times x times x, right? X times itself 3 times. And y the fourth is y times y times y times y. Okay. So again, 2 of a kind comes out. So let's figure out what our answer is. So 2 is still sitting in front. Okay, now we're breaking down our radical here. We have a pair of 2's, so that comes out. Another pair of 2's, so that comes out. My 3 is still left underneath. If I look at my x's, I have a pair of x's, so that comes out. There's still one more x left. There's nothing more I can do with it. If I look at my y's, I have a pair of y's. That comes out. And another pair of y's. That comes out. Are there any other pairs left? No. Alright, so anything that's left has to go under my radical. So I still have my 3. I still have an x. Okay. So again, anything that's a pair comes out. Anything else is left underneath.
And yet it's pairs because it's the index of 2.
Right now we're dealing just with square roots. Okay, so let's simplify this. What's 2 times 2 times 2? 8. X. And what's y times y? Y squared. And then square root of 3x is that. And that's our final answer there. So again, we break it down. Look for pairs, pull it out. Pull, pair, pull it out. Pair, pull it out. And then simplify. Alright, questions on number 2? Alright, let's do number 3 together. Alright. So, with number 3, let's think back to our product property. What is this the same thing as? If I'm multiplying, what do I do? Good, square root of 16. We multiply the radicands together, so 2 times 8 is 16. Okay, so let's break down 16. Alright, so a factor of 2. How many times does 2 go into 16? 8 times. Divide by 2 again. How many times does 2 go into 8? 4. Break it down again. How many times does 2 go into 4? Good. Alright, 2 of a kind. So that comes out. Another pair. That comes out. Is there anything left underneath your radical? Are there any factors left? No, there's nothing left underneath your radical. So you no longer have your radical there. We pulled everything out in front of it. Technically what we're doing is the square root of 1, but the square root of 1 is just 1. We don't have to write that. Alright, what's 2 times 2? 4. You could have also recognized from here, what's the square root of 16? 4. Alright, questions on that? Okay, then the last part of our notes. So simplifying cube roots is very similar. So cube root is where we have the 3 as our index. Now, because our index is 3, guess how many of a kind we need to have? 3 of a kind, yes. So it's very similar, except we circle groups of 3. So simplifying cube roots is very similar, except for we circle groups of 3. 3 of a kind. And again, bring one number outside and leave out the other 2 numbers. Singles and doubles stay inside. So again, we're going to break it down. Groups of 3 come out in front. Groups of 3 come out in front. Anything else stays inside. Alright, so our first one, 16. Let's break it down. Alright, it's an even number, so we divide by 2. How many times does 2 go into 16? Good. Divide by 2. How many times does 2 go into 8? Good. Divide by 2. Alright, so again, the difference now is we need 3 of a kind. My index is 3, so I need 3 of a kind. Alright, so now I'm circling 3 of a kind. So that comes out in front. Just one of them comes out in front. Do I have another group of 3? No, there are no other groups of 3. But is there anything left over? What's left? 2. So I still have a cube root of 2. Notice you need to be very careful that you follow the same index. If you would have left out your index here and said 2 square root of 2, that's not correct, because a square root of 2 is not the same as a cube root. Alright, so again, 3 of a kind comes out in front, and this 2 is left inside. Alright, next one. Alright, this one looks like it might be a bit of a doozy. Actually, let's do number 3 first. It's a little bit simpler. Number 3. Alright, what's our rule for division there? Should we simplify that first?
Yes.
Yes. What's 375 divided by 3? 125. Much nicer to work with. Alright, let's break down 125. Notice it ends in a 5. So it's divisible by 5. Alright. How many times does 5 go into 125? homework. Use your calculator to help you out. 125 divided by 5. 25. Good. Okay. 25 divided by 5. Alright. 3 of a kind. That comes out in front. Is there anything left? No, so there's nothing left underneath my radical, so we no longer need a radical. My answer is just 5. And the cube root of 125 is 5. So after you've simplified it, you can put in your calculator cube root of 125. If it's a decimal, though, that means you have to go through into the ladder method, because I will not accept 2 point something for number 1. I need to see 2 cube root of 2. All right, let's do number 2, the crazy one. Alright, so again, my 4 is still hanging out in front. So let's break down my 128. Alright, 128 divided by 2. You guys get 64. You're just, I need an extra check, didn't you calculate? Did we get 64?
Yeah.
Alright, 2 goes into 64. 32 times. We're just dividing them in half each time, right? 32 divided by 2? 16. Divide by 2? Divide by 2?
4.
Divide by 2? Oh, finally. Almost looks like a cake. Alright, again, our index is 3, so we need 3 of a kind. Alright, so there's one group of 3 that comes out in front. Here's another group of 3 comes out in front. Okay? We still have a 2 left inside, right? But we didn't take a look at our y's and z's yet. So y squared is y times y, and z cubed is z times z times z. Alright, we need 3 of a kind. Do I have 3 of a kind of my y's? No, so that's going to be stuck inside. I'm going to put a box around what's left inside. Alright, do I have 3 of a kind of z's? Yes, so this comes out in front. Okay. So I pulled everything out in front that I can. Now let's see what's left inside. And again, notice it's a cube root. I have 2. What's y times y? Good, y squared. Alright, let's simplify. What's 4 times 2 times 2? 16. So 16z cube root of 2y squared. And that, folks, is your final answer. 16z cube root of 2y squared. Alright, questions on that? Okay, let's fill in that last little piece. Alright, so that was a cube root, index of 3. How do you think we simplify 4th roots? Instead of having groups of 2 or groups of 3, what do you think we need? Yes, groups of 4. Groups of 4 of a kind. What about 5th roots?
Groups of 5.
Groups of 5 of a kind. So make sure you pay attention to the index to let you know how many of a kind you need to pull out. Questions on that? We still have about 4 more minutes, so I'm going to go ahead and give you your homework to start working on that. So you can ask your questions now. And we spaced out the homework to give you some more room for writing.